Okay, guys, this is for the Unit 3 test for Miss Metter. It's on conic sections. That's sections of cones. That includes parabolas, ellipse, circles, and hyperbolas. Let's start with number 1. Starting off with parabola. It's a sideways parabola, which means it would be a x equals y squared parabola. And so the first thing you know, you got to find out here is the vertex. The vertex is this point right here on the parabola. So the vertex, if you start at the origin and count over, we're going by ones here, 1, 2, 3. So over here, 1, 2, 3, 4, and up 1. So your vertex is going to be at 4, 1. All right. The focus, that's singular for focus. If it's plural, when you have two, you call that foci. You have 2 of those on an ellipse or a hyperbola. The focus is always on the inside of the parabola or on the inside of the ellipse or the hyperbola. So the focus is this little point right here. All right. And you're going to notice they didn't put it at a nice spot. I'm not sure why, but this is 4, so that would be 5 and 5 and a half. And the reason why I'm guessing it's a half is because I'm looking down here in the answers and they're in halves for the directrix. And remember, the distance from the vertex to the focus is called P. All right, that's the distance from the vertex to focus. It's also the distance from the vertex to the directrix. All right, so they are equally distant from the, that's horrible on the drawing, I apologize, but that's the distance from the vertex to either the focus or the directrix. And so that looks to be about 1.5, all right? Now, you don't want to use mixed fractions, so you convert that. Your calculators will do that on alpha y equals. You can make it, choose number 2, put it in as a mix, change it to an improper by going alpha y equals number 3, or 2 times 1 is 2 plus 1. 2 times 1 is 2 plus 1 is 3. That would be 3 halves. Nice 3 right there. So I want to go 1.5 to the right, which would take you to, if we start at 4, 5, 5.5. Okay, so the x value of the focus is going to be 5.5. Which as a mixed fraction, that is a mixed fraction, so 2 times 5 is 10 plus 1 is 11 halves. That is the x value of the focus. So we got 11 halves, and then you're still just going up 1. Okay? Now the directrix is an equation of a line. Guys, any vertical line, a vertical line is going to be x equals some number. Do that. So I'm learning how to use this board. I apologize. So we got x equals some number. Oh, I think that's better. All right. So if you look down here on the directrix equations, your multiple choice, or as I like to call it, multiple guess, A is an x equals, B is an x equals, C is y equals, and it's an equation of a line like that has a slope of 11 and y-intercept of 2, and this is y equals 5 halves, which is a horizontal line at 5 halves or 2.5. So our line, if you start at the origin and count over, is 1, 2, and then at 2.5. All right, 2.5 is going to be 5 halves as an improper fraction. So that is question number 1. All right, question number 2 says, find the equation of the parabola with a focus of 0, -11, and a directrix of y equals 11. So I like to get like a rough sketch of this. So give me a second. I'm trying to make the line less thick. Oh well, we'll just go with it. So if I got y equals 11, let's just say that's 11, and I got a line through there. We'll use a red one here. Ooh, nice line. Now you know why I'm not the art teacher. All right, that is the directrix, y equals 11. That's a horizontal line. And the focus is at 0, -11. Okay, so I'm going to have to extend down here. a little bit, try to make it somewhat symmetrical. And that's the focus. Okay, now remember the focus is on the inside of the parabola and the directrix is going to be on the outside. So the vertex is halfway between those 2 points. Well, halfway between -11 and 11 is 0, 0. So that's going to be our vertex. All right, and I know that the focus down here, has to be inside the parabola. So I know my parabola is doing a little something like this. Okay? So it's going to be a y equals, all right, which you already see on the answer choices. We know the vertex is at 0, 0. Now, to put this in, I'm going to assume, I'm not sure if it wants it in standard or vertex form. I'll do both for you. Vertex form is y equals a, parentheses, x minus h, parentheses, z squared plus k. And h and k is your vertex. Okay? Now, your a is actually based off of the p. P is the distance. P is the distance between the vertex and the directrix, or the distance between the vertex and the focus. They are equally distant from the vertex. So P is just a distance. So that's going to be 11. So we know P is 11. Okay. And we're looking for A. So there's 2 equations that you can use. You really just need to memorize one and know how to manipulate equation. You can use P is equal to 1 over 4A, but we don't know A. Or if you multiply both sides by 4A, you would have 4AP equals 1. And then solve for A, you would divide by 4P, divide by 4P. So if you divide by 4P, you get A equals 1 over 4P. So you'll notice either one you use, it's either P equals 1 over 4A or A equals 1 over 4P. We're looking for A, we know P. So A is 1 over 4 times 11, which would be 1 over 44. Now you got to be cautious right here. If the parabola was opening up like that, your A is going to be positive. If your parabola is opening down, your A is going to be negative, less than 0. So even though I have A as 1 over 44, I'm going to make it negative when I write this equation. Hopefully you can save that, and I'm about to clear some of this out where I can solve it. All right, so let me go ahead and write this over here. A is going to be negative 1 over 44. Why? Because it's opening down, okay? So let me erase some of this. All right. Oh, that's nicer. Learning the board, y'all. Let's go ahead and get rid of that. All right, so this one's actually nice because the center is at, not center, the vertex is at 0, 0. So if you were to go back over here, and we have y equals negative 1 over 44 because that is A. H is 0. K is 0. So what's going to, oops, let me erase that. Oh, I didn't mean to erase the question. Oh well. Can you go back? There we go. Maybe I'll get the hang of it. All right. So we got a 0 there. So plus 0, that's nothing. That's gone. Bye, Felicia. All right, x minus 0 is gone. So you're left with x squared. So your equation is y equals negative 1 over 44 x squared. And that's your equation. And that is number 2. Okay, question number 3 says determine the vertex, focus, and directrix of the parabola y equals 3 parentheses x minus 6 quantity squared. So it's in vertex form. Let's recall that vertex form is y equals a parentheses x minus h squared plus k. So whoever's inside with x is the x value of your vertex. Whoever's on the outside is going to be the y. Now remember, when you bring something out of the parentheses, it's going to change signs. So your h is actually positive 6. So your vertex, because your vertex should be h comma k, all right, it's going to be positive 6 comma 0. 6 comma 0. Now, to find the focus and the directrix, you have to find the value of P. Now, what we know is A right now. We know A is equal to 3. So I'm going to use the equation P equals 1 over 4A. So that's going to be 1 over 4 times 3, which is going to give you 12. 1/12. That is your P. Now, I like to visualize this parabola, and you have a graphing calculator, so if you go to your y equals screen, you can actually see what this graph looks like, y equals, but just a rough sketch of it, it's going to be right 6, and the vertex is at 6, 0, and the 3 actually has to do with the vertical stretch, so it's just going to make it more narrow than another. But you see that it is in the vertical, it's opening up. So your leading coefficient was positive, true. So your focus is going to be somewhere in here, and your directrix is going to be somewhere out here. All right? So since the focus is always inside, now notice, this ordered pair is going to be 6 and then some y value. The y value is no longer going to be 0. So the formula for this is going to be h comma k plus p. Okay, so the x stays the same. That's going to be 6. And then you're going to take k, which was 0, and add your p, which is 1/12. And 0 plus 1/12 is 1/12. So we have 6 comma 1/12. My graph is obviously not to scale because I went up. So apparently right there is 1/12. All right. Well, we need to go 1/12 below the vertex to get our y equals there. See, this is 6. Where's the y? Well, it's going to be y equals negative 1/12. Because what you're doing is, this time you're going outside the parabola. So remember, y is associated with k. So this time it's k minus p. When you go in the focus, you add the p. When you go outside to find the directrix, you subtract p. So this is going to be 0 minus 1/12. Which is going to be negative 1/12. So the equation here is y equals negative 1/12. And those are both equally distant from the vertex. Okay, this is question number 4. It wants you to find the vertex, axis of symmetry, x-intercepts, y-intercept, focus, and directrix for the parabola. Sketch the graph, the correct graph of the parabola. That seems like a lot to do. Well, first of all, it's in vertex form, all right, which is nice. So, vertex form, remember, it's y equals a, parentheses x minus h, quantity squared plus k. So for the vertex, the number inside with x, which is right here, the number inside with x is plus 4. Now when you bring it out of the parentheses, you change it to negative 4. So we have negative 4, comma 2. K is the number on the end. You do not change the sign of the number outside because it did not come out of parentheses. So that's pretty easy. So now, don't forget your parentheses there. Now, let's talk about a rough sketch of this. If we plot negative 4, 2, left 4 up 2, we would be about right here. All right? The parabola we should know is opening up because it has a leading coefficient that's positive. So our parabola, this is an extremely rough sketch, is looking a little something like that. Okay? That's really bad. But the axis of symmetry now, we haven't talked about that yet. It is the vertical line that cuts your parabola in half. And it should be a mirror image from this side to that side, but I didn't draw well. Okay? So that equation is going to be x equals, because look, x equals 0, it's x equals -4, 0, x equals -4, 1, x equals -4 and 2. All the x's on all those points throughout are going to be x is -4. So the equation of the axis of symmetry is x equals -4. It wants to know the x-intercept. That's where it crosses the x-axis. You will notice it never crosses this axis, so there are no x-intercepts. All right. The next part, it wants the y-intercept. And hopefully you got this, because I'm going to have to pause and open another screen. Okay, so now it wants the y-intercept. Now, let me redraw the graph that we had a while ago. This is not cooperating with me. There we go. All right. So the graph we had a while ago was at -4, 2. All right, and then I'm not really sure how wide to make this, but I know it's opening up, and it's going to cross the y-intercept. The y-axis is going to be somewhere over here. All right, but the y-intercept, you got to remember, this is the value of y when x is 0. So x is 0 here, and then wherever it crosses the y is going to be the y value. So to find the y-intercept, you let x equals 0 in the equation. So you would say y equals 1/4 x is 0, plus 4, quantity squared plus 2. Now you can type all that in your calculator, or without a calculator, you would do parentheses first, then the exponent, so you would square it, square the 4, which would give you 16. 1/4 of 16 is 4, and then you have 4 plus 2, which is 6. So my graph is a little off. Mine looked like it crossed at 8. It should have been crossing right here. Now that's important, because when you go to use the graphing tool, you're gonna plot the vertex first, -4, 2, and then you're gonna have to have at least one other point, and so 0, 6 is gonna be a good point to plot. So 0, 6 is your y-intercept. Now, to find the focus and the directrix, we have to either know A or P, okay? So remember, in your equation up here, the 1/4 is your A. So I know A, I need to find P. Well, how do you find P? P is 1/4A. So it's going to be 1/4 times 1/4. That was nice of them, because 4 times 1/4 is 1, so 1/1 is 1. So what that's telling me, that's the distance from the vertex to the focus, or the vertex to the directrix. So it means the focus is going to be up here, 1 unit inside of the vertex, and then the directrix is going to be 1 unit down, and it's going to be this imaginary line that's sort of, it's perpendicular to that axis of symmetry we found earlier. So this directrix is going to be y equals, it looks like 1. All right, and the focus is going to be -4, 3. Now, if you needed an equation for that, because some people like equations, so you know that the focus is going to be, the x is -4. Remember, to find the focus here, it's h, that doesn't change, but it's going to be k plus p, because it's inside, so you add p. To find the directrix, it's going to be y equals k minus p. All right, so that's why here k in our problem was 2. Okay, because the vertex was, remember the vertex was -4, 2. So on the focus, we know the focus is -4, and then we're going to add p, so we're going to add 1, so that's -4, 3. But I really like to get a visual on these. That way, if you get confused on your formulas, it'll help you out. So left 4, up 3, there is your focus. And then down here, below 1, k was 2, k minus 1, 2 minus 1 would be 1. So y equals 1 is the equation of this line right here. Woo! All right. And then when you go to graph it, you're going to click the graphing tool. Make sure you choose the parabola that's opening either up, okay, because we don't have a sideways parabola right now. It's up or down. You're going to plot the vertex, which was negative 4, 2, and then you're going to need another point. And I would suggest using that point. Don't use the focus. That's not on the parabola. You got to use a point that was on the parabola, and 0, 6 was the y-intercept. So you could plot that, and then it'll graph your parabola. Okay, question 5 wants you to find the vertex, axis of symmetry, x-intercept, y-intercepts, focus, and directions for the parabola. Now I want you to notice, and we got to sketch it, it's x equals this time. So just to remind you, when it's y equals x squared, that's going to be opening up or down. Down if it has a negative leading coefficient. When it's x equals y squared, that's going to be a parabola that either opens right or left depending on the leading coefficient. If the leading coefficient is positive, it's going to open right. Now I want you to notice over here, your leading coefficient is negative, so it's going to open left like this. By the way, you can't graph this on your calculator because you don't have an x equals graph screen, you only have a y equals graph screen. So now the the vertex form on this is x equals a parentheses y minus k, notice that's different than the last one, squared plus h. K goes with y, h goes with x. So since x is over here on the left, all right, the number inside with y is going to be the y value of the vertex. Now your vertex is still h comma k. However, this is no longer x. That's going to be with your y. So our vertex, the h, is going with x. So whatever's out here at the end is what your x value, your vertex is. This time it's plus 5. You do not change the sign because it's not in parentheses. Now what goes with y on the vertex is going to be positive 4 because you're bringing it out of the parentheses, so you change signs. So right now, I know that the graph of this is right 5 and up 4. So it'd be right there. And we know it's going to open to the left, okay? Now, let's do the next thing first, and then we'll talk about some other stuff. So it says the axis of symmetry. So the axis of symmetry, if the parabola is opening to the left, which maybe I need to do a little rough sketch of it to help. The axis of symmetry is this line right here. It's the line that cuts the parabola in half. Now that is a horizontal line, which is y equals a number. So what does y equal there? Well, y equals 4. So that is our axis of symmetry. So on the click down, it's y equals and then 4. Okay. The x-intercepts. So the x-intercepts are the value of x when y is 0. So x-intercept, you're going to let y equals 0. All right, and I'm going to come down here and do that. So in the equation, it's x equals negative 1/2 0 minus 4 quantity squared plus 5. Okay, I am not going to take the time to do that all out. You can type in the calculator. Negative 4 squared is 16. Half of 16 is 8, but it's negative, so that's negative 8 plus 5, which is, woo, my 5, woo. So that's going to be x equals negative 3. Now, that's an x-intercept. That's the only x-intercept. It's the value of x when y is 0. So it wants it as an ordered pair because an intercept is an ordered pair. All right, notice, make sure you read your instructions on the test. So my x-intercept is going to be negative 3 and x, I'm sorry, that was x when y was 0. That's the only x-intercept. Okay, I think there's a second part to this question. Let me pause. Okay, so it wants to know the y-intercepts. Now the y-intercept is the value of y when x is 0. But I want to show you something. Let's see, where was our vertex a while ago? Our vertex was at 5, 4. So 5, 4. And we said it was going to open this direction, right? So it is going to cross the y-axis couple places, but we got to use our equation, let x be 0 to find the y, because we're looking for y, so let x be 0. So to find the y-intercept, whoa, that was crazy, my bad. So the y-intercept, we're going to let x be 0. And I'm going to do this over here on the right because it's going to take a little bit more. So using your equation, you're going to put in x is 0. And you got negative 1/2 parentheses y minus 4 squared plus 5. So the first thing you're going to do is minus 5 on both sides. And that's going to leave you with this. Next, you want to get rid of times negative 1/2. So you're going to divide by negative 1/2. Or divide by negative 1/2 is the same as multiplying by the reciprocal, negative 2. Multiply by negative 2. Because negative 1/2 times negative 2, that cancels. All right, so we got positive 10 equals y minus 4 quantity squared. Oh, this should be fun. So we got to get rid of the square next. So we're going to take the square root of the left and the square root of the right. Now when you do this, it's not just going to be square root of 10, it's going to be plus or minus the square root of 10. So we could have square root of 10 equals y minus 4 because these cancel. Or you could have negative square root of 10 equals y minus 4. Now to solve for those y's, you're just going to add 4 to both sides. Now you can't add 4 to a radical. So it's going to be 4 plus radical 10. And this one's going to be 4 minus radical 10. Now those are your y-intercepts. So you got to write them as ordered pairs. And it does say type an exact answer using radicals. So this is when we let x be 0. So our first one was 0, comma, 4 plus radical 10. That's the first point because the y-intercept is the ordered pair, comma, 0, comma, 4 minus radical 10. So you gotta know how to solve a quadratic equation like that. Now the focus and the directrix. Remember the focus is on the inside and the directrix is gonna be on the outside, but we have to know P, the distance from the vertex. So remember to find P, it's 1 over 4a. RA was negative 1/2. So 4 times a negative 1/2 is going to be negative 2 because half of 4 is 2 and we got a negative, so that becomes negative 1/2. The negative is really irrelevant, okay? Because P is a distance is always positive. But the reason why we have an A that's negative, a P that's negative, because we're opening to the left. Remember that. Okay, so let's talk about the focus. So the focus should be right here-ish. Actually, take that back. The focus is going to be 1/2 inside, so right there, and 1/2 outside. So the directrix is going to look like this, and the focus is just a point. Please ignore that point. All right, so notice the vertical line, the directrix is going to be a vertical line, so it's x equals. So let's go ahead and talk about it. X equals, because it's easier. And we were at x equals 5 on the vertex, and we went up 1/2, so that's 5 plus 1/2, which is 5 1/2, or 11/2. So that is the equation of your directrix. X equals 11/2. Okay? Let me talk equations for a second. Now, notice you added to the 5. You added to the x. Okay? Because we're going to the right of the x value of the vertex and to the left. So to get these formulas, the focus is going to be your h plus p, and whatever your k was. And then your your directrix is going to be x equals h minus p. think about that for a second. Oh, P was a negative. So plus a negative is where that became a plus. So technically it's H, which was 5. I'm telling you, my handwriting is garbage. I apologize. So it's 5 minus that negative 1/2. Okay, so P is negative 1/2. That's important if you want to use the formulas, all right? Then up here, let's go back to focus. It's going to be 5 plus a negative 1/2, comma, K, and K was the vertex 4, the Y value of the vertex. So 5 minus a half is 4.5, and 4.5 is 9/2. Now let's check that. So the focus is 4.5, so look, right 4.5, and then up 4. The formulas are great, but to me, if you draw it out, it makes sense. Especially if they pick nice numbers, they don't always do that. All right, question 6. It says find the equation of the parabola determined by the given information. And all that gives you the vertex and a directrix. So I like to plot this, okay, because you're going to notice 3 of the answers are x equals, 1 is y equals. My guess, if I was doing process elimination, it's probably going to be an x equals, but let's get a visual of this. Here we go. So we have the vertex at 0, 0. And the directrix is at x equals -5. Now, x equals is a vertical line. 1, 2, 3, 4, 5. So the directrix is doing a little something like this. Now, this is your vertex, okay? The directrix is outside and perpendicular to the axis of symmetry. So I know right now that my parabola is doing this, okay? So it is definitely an x equals equation. It's going to be x equals y squared something, all right? Since the vertex was at 0, 0, there's nothing attached to y or x. So we just have to find out the a. Now remember, to find a, it's going to be 1 over 4p. Also, I want you to notice that the parabola is opening to the right, so your a is going to be positive. All right. P is the distance from the vertex to the directrix. So that's a distance of 5. So we have 1 over 4 times 5, which is going to be 1 over 20. So that's your A. Now notice, we know it's not y equals. We know it's not 1/5. Is it negative 1/20 or positive? Well, it's positive because your parabola is opening to the right. How do I know? Because I know that the directrix is outside and perpendicular to this axis of symmetry. The axis of symmetry is y equals 0. So your directrix and your axis of symmetry are always perpendicular. Okay, question number 7 deals with an ellipse. Some people might call that an oval, but if you've been educated, that is an ellipse. Now, the standard form for an equation of an ellipse is x minus h squared over something plus y minus k squared over something equals 1. That's an equals to. Let me get that off. All right. Now, depending on the major axis. Now, the major axis is going to be the longest axis. So here the major axis is x because it's longer in the x direction than in the y direction. Now, there's little a and there's little b, and that's going to be the distance from center to the vertex. To your vertices, I guess I'd say, or to one vertex. All right, and D is the distance, and your vertices are your major ones. So it's these blue dots on your picture, okay? Let me take those off. All right, and B is going to be the distance from the center to the minor vertices. I'm going to abbreviate here, don't hate abbreviate. And by the way, H and K are no longer a vertex. It's the center of the ellipse. Okay, so the center, hopefully you can see this, the center, which is HK. Remember, what's inside with X always goes in the X position. What's inside with Y goes in the Y position. When you bring them out, parentheses, change the signs. But here the center is at 0, 0. So that's going to be nice here for us. That's your H and your K. All right, 0, 0. Now, since the major axis is X here, this number underneath would be A squared and this is B squared. This is all not necessarily needed on this problem, but it's going to help you for future problems. So first it wants the coordinates of the foci. Really, I would ask for the coordinates of the vertices first, or the center. So let's start at the center because it's actually the easiest. The center is going to be 0, 0. Yay, we got something right. Now these blue dots, those are the major vertices. All right, you can notice that's at 6, 0 and negative 6, 0. So the answer there is C. Now, you'll notice the green dots, remember a focus is singular, that's inside a parabola. So like a focus is inside a parabola, or like this. But when you have an ellipse, you have two, which is foci. Some people say foci, I was always taught foci, so I'm going with what I was taught. They're the green dots. Now, you're going to notice that your multiple choice here, negative 6 and 6, 0 and 6, 0, those are your vertices, so it's definitely not your foci. 0, 3 and 0, negative 3 are your minor vertices, so it's definitely not that. So it's process elimination here, but you're going to need to know this somewhere else. Now, to find the foci, you need to know little c. So y'all probably remember the Pythagorean theorem. A squared plus B squared equals C squared. Well, this is a little different. It's A squared minus B squared equals C squared. And the way I always memorize this is for an ellipse on the major equation, you're adding the x squared and y squared. So to find little c, you subtract a squared and b squared. So in the main equation, you're adding. So to find little c, you're going to subtract. Well, what is A and B? A and B is the distance from the center to the vertices, to the major vertices, and B is the distance to the minor. So if we were to look, how far was it from the center to the vertex? That's a distance of 6. So little a is 6. All right, little b is the distance from the center to the minor vertex, which is 3. So little b is 3. And so what you get is 36 minus 9. Okay, now, that's c squared. 36 minus 9 is 27. When you solve for c, you get the square root of 27, which the square root of 27 needs to be broken down and reduced. That's 9 times 3. Why did I choose 9? Because that's a perfect square and 3 is 9. So the square root of 9 is 3, radical 3. That's where they're getting the 3 radical 3 here. And to find the foci, the formula for that is going to be h plus or minus c, comma, k. Because it goes back to the center. And notice you're going to be adding it to your x value of the center, not your y value. All right? So it's 0 plus or minus 3 radical 3, comma, 0. So that's where they're getting the two answers, negative 3 radical 3 and positive 3 radical 3. Okay, question 8. Find the equation of the ellipse described below and sketch its graph. I would first start by sketching a graph. So it's giving you the foci and the y-intercept. So let's see what this is looking like. So 6 and negative 6, let's just say this is negative 6 and this is 6. Those are the foci. So those are the points on the inside of this ellipse. Now your y-intercepts are going to be your other vertices. Now I want you to notice something on all the multiple choice. X squared and y squared don't have anything added to them. okay? So the center is going to be at 0, 0, all right? And if these foci are on the x-axis, that means the vertex, the major vertices, are going to be outside here, okay? And it tells you the y-intercepts are 8 and negative 8. So this is a really rough sketch. Now, right now, oh, that's horrible. Anyway, so right now I know that these vertices over here have to be they have to be bigger than 6 and negative 6, but I don't know if they're as big as 8. So what we got to do, first of all, I'm just looking down here at the multiple choice. I'm pretty sure you could probably figure it out. Maybe not. No, not necessarily. Well, I know it's not B. I know it's not C. Right now I'm going with the letter D. However, I want you to notice they're counting by 2's here. 2, 4, 6. Huh. Oh, y'all, scratch that. Scratch all that. I just drew that wrong. Just drew it wrong. Okay, we're gonna have to start over. No, we're not. Okay. I apologize. I'm learning how to use this darn board. It likes to erase this. I got this, I used the snippet tool and posted this, and then I had to enlarge it. So bear with me here. I apologize. So it's always good to get your ordered pairs down right. This is actually going to be easier now. So we have 8, negative 8, and then we have 0, 6, and 0, negative 6. Those are your foci. So I know it's doing a little something like this. So my major axis is the y. All right. Now, let's say we didn't know that, but I know by the graphs down here, the only one that has x and y intercepts are 8 is D. But I want to go through this with you. So the major axis from the center to the outer edge, okay, see if I can use this pen for a second. That is going to be your A. So that's 8. And then the distance from the center to the minor vertex is going to be your B, which we don't know what that is right now. But since y is the major axis, 8 squared should be under y. So 8 squared is 64. This is the only one of those that works. Now, this distance right here, B, apparently is the square root of 28, because when you square that, you get 28. The standard form of an ellipse, remember, is x minus h, quantity squared, over some number, y minus k, quantity squared, over some number, equals 1. When you can figure out who the major vertex is, this is your a squared, this is your b squared. So b squared equals 28, so b must equal the square root of 28. Okay, that's all for that problem. Okay, question number 9 says sketch the graph of the ellipse and identify the foci. I want you to notice they got x and y backwards here because sometimes they'll put the major axis first. The reason we know y is the major axis is because it's the bigger number underneath. So now remember, that's not a, that's a squared. So little a is going to be the square root of 9, which is 3. B squared is the number underneath the minor axis, 4, so little b would be 2. All right, so from the center, and the center is going to be 0, 0, because that's your h and your k. Now this, remember, h goes with x. I know it doesn't matter here, but h always goes with x, k always goes with y, but nothing's attached, so it's 0, 0. So we want to go 3 in the y direction and 2 in the b direction. Now these are going by 2's again. 3 in the y direction, that goes up 3, that goes up 2. So a is gone. This goes up 2, down 2. This goes up 3, down 3. This goes up 2, 4, 5. So by process elimination, I got the graph. Okay, now the foci, you got to remember, is on the inside. I don't know if you can see right there. It's always going to be on the inside of the major axis. Now, remember H comma K is your center. Our major axis is Y. So the formula, we're going to add and subtract C to K. Now what is C? You have to go back to that formula from a previous question. C squared is equal to A squared minus B squared. Not the Pythagorean theorem here, because we're adding, in the ellipse equation, we're adding x squared y squared. So on the C equation, we're subtracting A squared and B squared. So C squared is going to be 9 minus 4, which is 5. And then the square root of, ooh, and the, hello, it's just 5. And then we're going to take the square root of that and the square root of that to solve for C. So C is 5. Actually, it's plus or minus 5. That's why you do a plus or minus over here. So we have 0, comma, because H was 0. 0 plus or minus the square root of 5. 5 cannot be broken down as a radical, so your ordered pairs, you're actually going to have 2 ordered pairs. Sorry, not that. Your first ordered pair is going to be 0, comma, square root of 5. The second answer is 0, comma, negative square roots of 5. And the square root of 5 is like 4.1, I don't know, 4 point something. So 0 up 4. No, sorry, it's 2 point something. Man, y'all, it's 8:19. I should already be in bed. So 0, 2 something, and then, so actually your foci would be a little bit higher than 2, a little bit lower than 2, because that's 2 point something, negative 2 point something. So those are your foci. Make sure you type them in as ordered pairs. Make sure you separate with a comma. Okay, number 10, it says find the graph of the following ellipse and then identify the foci of the ellipse. First of all, I notice it is not in standard form. For an ellipse, it's supposed to be an x squared plus a y squared equals 1. So how do I make this equation equals 1? I got to divide everything by 36, okay? When I do that, 9 over 36 is 1/4. 4 over 36 is 1/9. So I'm not going to write 1x squared over 4 or 1y squared over 9. I'm just going to, because the 1 is understood, okay? So that's really not there. And then 36 divided by 36 is 1. So now we have it in standard form. And let me just go on and take off that 1 where that doesn't confuse anybody. And it erased half my stuff. So, who is the major axis is what you need to ask yourself first. Well, who has the bigger number underneath? And it's y. So, remember the numbers underneath. The biggest number is always your a. So we have a squared equals 9 or a equals 3 because you got to take the square root. B squared equals 4 or the square root of that is 2. So you know your A and B. Remember, that's the distance that you're going from the center to the vertices. Now, the center again is 0, 0 because nothing is being added or subtracted to y. They're keeping it sort of easy for you here. So we need to go 3 in the y direction because 3 squared is underneath y, and we need to go 2 in the x direction. Now, I'm noticing the scale here, this goes out to 20, so I'm guessing we're going by 4s. 4, 8, let me just try 4, 8, 12, 16, 20. All right, so we're going by 4s. I'm supposed to go 3 in the y direction. So 3 would be a little bit less than 4. That looks like it's exactly 4. Plus my x direction is 2. So you'll notice on A, it looks like it goes right to, because it's going half of 4, and it looks like it gets close to that 4, but that would be 3. I'm thinking this is the 1. All right, but let me check the others. This is obviously not it because that's 4, 8. That would be 0, 8. That's not 8. We're only supposed to be going 3 in the major direction. And this is only going about 2 in the major direction and 2 in, and actually that's not even an ellipse, that's a circle. So bye, Felicia. Okay, and here the major axis is x. One thing I should have mentioned, when you notice that y is the major axis, look at your graphs. B is major in the x because it's wider in the x. Y here is bigger, but it's going up 8 and down 8, not 3. And then this is a circle, So it's definitely not that. So by process elimination, honestly, you could have got A. But we got to talk about foci. So for the foci, remember H comma K. Now the foci is going to be inside of your Y. So the X stays the same, and you're going to either plus or minus C. Okay, plus or minus C. All right, what the heck is C? Remember, C squared on an ellipse is A squared minus B squared. Now, A squared was 9, B squared was 4, so C squared is 5. You got to square root that, though, to get plain C, which is plus or minus the square root of 5. So that's why we're adding, subtracting square root of 5 to your K. So this was 0. Where did H and K come from? Remember, HK is the center of your circle. Of your ellipse. And so it's 0, 0 plus or minus radical 5. So your two order pairs are going to be 0, positive radical 5, comma, 0, negative radical 5.